Well, it's the opposite. Can't be planned until working. Then I tried to find a way to run along the way I'm going to be. I help make a friend.
Guess it's time. I'm Hans-Kristian. It's great to be here. I think I've given a talk every year at Vulkanised or Dev Days, so I should get a veteran badge or something now. This talk's going to be about SPIRV-Cross, which is a tool I'm developing. It's called Taking SPIR-V to the Next Level, but I realize that's probably a vague title. So, how many have heard about SPIRV-Cross? Oh, that's pretty good. How many have tried it? How many are shipping it in some way? Nice. Okay, so if you don't know what it is, it's a tool that allows you to cross-compile SPIR-V shader code to all the things, like Metal, HLSL, GLSL, all the various flavors and dialects of these languages. And it also does reflection to some degree, but that's a kind of simple thing to do. It's on GitHub, it's a Khronos hosted project, and it's pretty good to be maintaining it. So I actually gave a talk about this topic last year, which was called the War Stories, which was a long-form rant where I talked about all the stupid things sharing languages can do. And especially Metal is very fun to rant about. I'm not trying to repeat that talk, so you can see the recording on YouTube. I think it's on YouTube. Lots of technical detail. I'm not trying to repeat that. I'm trying to be a little bit more high level this time around, because a lot of interesting things have happened. So some things that happened was that I went independent, partly to work on SPIRV-Cross. It's now funded by vows, so I can be benevolent dictator for life. Yeah. That's great. That basically means I'm committed to keep working on this indefinitely, as long as there are users and people file bugs and issues. So the gist of it is that we want to compile to SPIR-V in some way. And if you have an engine, you need to, at least for Vulkan, you need to get to SPIR-V in some way. What I'm trying to argue is that you can use SPIR-V for way more than you would normally use it for. So there are three major ways to get to SPIR-V. Is the GL slang, which you probably might be familiar with, where you can compile Vulkan, just GLSL code to SPIR-V. That's the main path, if you will. But there's also a lot of HLSL work that's happened. Like you can use GL slang's HLSL support to get to SPIR-V. You can also use the Microsoft DXT compiler, which does not supports DX12 like the new bytecode format, but it can also target SPIR-V thanks to Google's efforts. Some interesting things you might want to do is emit SPIR-V directly from a shader graph. No reason to emit weird code which is compiled SPIR-V. Or you can make your own language, even like Leonard Ritter did with his scopes language, where you can target LLVM and SPIR-V, and uses that to goes through SPIRV-Cross and then targets this in GL, because Vulkan is very hard. Yeah, so you start in your favorite language. I'm using an example here, HLSL. I like GLSL, but yeah, this will make the code snippets more interesting. You go to SPIR-V, that's very binary format. You don't actually read that yourself, but you can do things like target all the things from HLSL. You can target ESSL 1.0 if you're still caring about class 2. I know some people do. You can target modern GLSL or GL 4.5 or something, or GL 3. You can also target Walkin Geocell, which might make little sense, but it has some use cases. You can target HLSL SM5, which would be D3D11. You can also target D3D9 even, but that's not really well tested. I know some people use it, but don't expect you to D3D9. And last but not least, there is Metal support. Metal is a fun language. No sarcasm there. Yeah, so a lot of work has gone into Metal over the last years because it's the most popular one because it's a very special use case that I'll get into. So I think this marks the new wave of shader cross compilation, if you will, where in the past you would have HLSL to Geocell using some random ad hoc tooling. HLSL-CC is probably the most popular one, but they're not really open source in a way that you still need to rely on some closed source component, like at least the FXC compiler, and running that through Wine somehow, and it's just messy. But I think this new wave is you start in HLSL. Most developers use HLSL. To go to target DX, you just use that. But to target everything else like GL, Vulkan, Metal, you can use SPIR-V. And I've seen several examples of this now, like the EA Halcyon engine uses this path where HLSL goes to SPIR-V to target Metal, and even AVX2, interestingly enough. Even the Microsoft's own cross-compilation solution, which is on GitHub, uses this code path, but it actually uses SPIRV-Cross to target D3D12 to D3D9, 10, and 11, which is really strange. They do, so that's cool. And on the right there, I have lots of nice tweets I like to read. People like to use SPIRV-Cross for their stuff, so very happy about that. It's very good to see happy users. That's basically the only reason I'm still working on this stuff. It's also part of the Walkin Portability initiative. And the Portability initiative is really just there to target Metal for the most part, because there is no way to use Walkin on the Fruit devices. So here SPIRV-Cross is used to runtime translate SPIR-V into Metal. And that's one of the reasons why Metal backend is so important, is that this is actually a critical path in some title. Like Valve ships Dota 2 and an artifact on it, and some other projects as well. So I mentioned Walkin Geocell White might be useful. I find it useful for two major things. It can actually do a thing I call a de-optimizer, which is where you take SPIR-V, you make that into Walkin Geocell again, and then you go back through GeoSlang to get you back to SPIR-V. Why would you ever do that? It actually de-optimizes aggressive single static assignment, which is what you get when you run SPIR-V opt. It's very weird looking code, but it's supposed to be more optimized. Turns out some drivers kind of don't like that in all cases. So to test workarounds, or just to check if this is the driver problem, going through a de-optimization step like this can actually help. It has helped isolate a few bugs in the past. There's also the debugging case, where if you want to debug a capture of a Vulkan app, you don't want to read a SPIR-V. That makes no sense. So one of my favorite use cases is in RenderDoc. Again, great tool. You can actually look at a pipeline, decompile a shader, edit the shader code in Walkin Geocell, recompile that, and see the updated results in the tool. That's like mind-blowing. But you kind of want Walkin Geocell output there, because you don't want to sit and edit shader code that looks like this. You just can't make that work. I think when I write the SPIR-V file, it takes 10 attempts to make it past the validator, and that's not fun. So that's another reason to have Walkin Geocell. There's also an interesting web tool that has been developed by Tim Jones over the last years. It's the Shader Playground. It's a really nifty tool where you can test random shader compilation stuff, where you type in some code. I want to use HLSL with this compiler, emit SPIR-V, go through SPIRV-Cross, test output. So you can explore the kind of output you're getting without investing a lot of time into integrating it or something. It's pretty useful. So really the goal, was the point of all this, it's to take SPIR-V and make it the de facto sharing language, because right now there just isn't one true way of. You have to deal with all the platforms, and they all have different sharing languages and different bytecodes, and it's a mess. At least 3 different ways with DX bytecode, SPIR-V and Metal. They don't have a bytecode, sadly. But this is all super tedious. It's painful. Everyone who has tried to do this has come up with a different solution with different problems. So I think SPIR-V is in the right place where it can serve as the standard sharing language for even all of these platforms that don't natively support SPIR-V. And that's what SPIRV-Cross is trying to solve, is to bridge the gap to all the other platforms and make SPIR-V all the things. And by widening the use of SPIR-V, we also get better validation, we get better optimizers, better GLSL, HLSL compilers, maybe even new languages to fix all the bugs I've been ranting about. It also encourages new tooling even, because if SPIR-V becomes the standard, then new tooling will pop up that's needed. That's good. So this is kind of a meta thing. As a kind of a maintainer of an open source project, it's kind of something I want to talk about because I have a very specific philosophy when it comes to how to deal with open source projects. And tools like SPIRV-Cross, they're never going to be perfect, because cross compilation is a big hack. And it's just impossible to be 100% completely perfect. There will never be a point where you can say, yeah, this will work forever, final version, I can go die outside the cliff now. That's never going to happen, because there will always be new extensions, there will always be extremely obscure edge cases in a certain compiler. Maybe you have to work around a driver bug with SPIRV-Cross somehow. Like a few metal bugs have actually been worked around in SPIRV-Cross, which is fun. But since we're never going to be perfect, there might be issues. So the way to fix that is just by being as responsive as possible. That means quick bug fixes, quick response, and review of pull requests. And you kind of have to sacrifice, like you're not going to spend 2 months making the perfect version of some kind of feature. I'd rather just iterate extremely quickly, because the worst thing that can happen is to let issue counts spiral out of control. Because as a user, if I'm making an issue or file an issue to a project, the worst thing that can happen is there's no reply, because it just drowns in the noise. Like if you're opening a ticket, oh, there are 1,000 issues open. That issue is probably never going to be fixed. And it's to build the trust with users over time that if you file a bug, it will be fixed, or I will look at it. And I think that's really important, because it takes time to make a good issue or a good pull request. And if you see that the maintainer doesn't do it properly, no one is going to spend time on that again, because time is money. Especially for developers who have to desperately ship next month due to a shader bug or something. Yeah, but the good thing about SPIR-V and kind of compilation projects is that it's super easy to reproduce. So here's a SPIR-V, it reproduces 9% of the time, great, we don't fix it. I mean, that's not what happens with games. Play 20 levels into this game and but what I want to get to here is that don't hesitate to file issues or feature requests. Just file as much as you like. Hopefully I have bandwidth to take care of it. I mean, I'm paid after all, so that's fine. Yeah, some statistics, some things these are things I look at all the time and I stress about them. If I see an issue count over 30, I start to stress out. If it's below 20, it's great. Zero open pull requests and 500 closed, that's probably the best statistic ever. And commit over time is pretty solid. I mean, not everyone cares about this stuff, but I think it's actually important. When I look at project, I can tell very easily what's going on. If I see 200 open issues and 300 closed, that's shaky. Or if there are like 20 open pull requests, that's also very shaky. So that's kind of the meta thing I want to get out of the way. This part of the talk is more about the progress that has been made since last year. I can't enumerate everything, but some of the highlights. So in a GLSL backend, that's basically the main backend. It's the one that maps closely to SPIR-V, so it's easy to cross-compile. Well, not really, but it's the easiest one probably. And all the work last year has been to keep up with the latest addition to Walkin, basically. And there have been lots of new extensions to Walkin Geocell, which is very important for debugging. If you're trying to debug the new features, you kind of want a cross-compiler to get back to GLSL. So some advances have been really amazing. We finally have 16-bit arithmetic and storage support. So that's in. You can cross-compile that. There's all the subgroup operations. That was probably 500 lines of code. There's the scalar block layout, which is like super niche if you're packing data in a very specific way. There's even buffer reference support, which I added recently. So we can actually have pointers in GLSL now. That's scary. There's also bindless, which is also becoming really popular, and the main thing to take care of there is to deal with the non-uniform EXT qualifier. There's also some advanced vendor extensions. Normally, I don't implement those. I only care about KHR and EXT because they're considered widely used for vendors. Vendor extensions, I kind of want the vendors to do the work for me, and they have done a little bit, which is great. NVIDIA contributed ray tracing support, so you can actually cross-compile ray tracing shaders now. I'm not sure if that actually works, but you want to be. Maybe you could do something crazy like write DXR shaders, get that through DXC to SPIR-V. I don't know. Maybe it works. That would be cool. AMD, I think that was Lou. I think you did that. Yeah, all the AMD specific Walkin Geocell extensions, like the barycentric support, the vertex fetch stuff, the fragment mask multi-sample thing. Basically, a whole list of extensions recommended, so you can use that. It's cool. I assume that was for debugging. Yeah. It's nice. And of course, a million small fixes and tweaks, which I don't have time to go through. HLSL backend has been fairly quiet, mostly bug fixes. I assume this is because most developers start in HLSL anyway, so there's very little reason to cross-compile to HLSL. Or it could just be the case that if you're cross-compiling to HLSL, you're probably using very simple shaders. That it turns out you get very few bugs anyways. One big or two big things I still haven't bothered with is geometry shaders and tessellation support. That will be fun. One day. No one has really requested it yet, so except for that one guy who requests everything on every project on GitHub. But, yeah. So if you have an actual use case for this, then do comment on the issues on the tracker. Just give me some priority on it. Otherwise, it might not happen until next year. I don't know. CPU targets is something that is rarely talked about. There was way back in the day, there was a C++ backend where you could actually take SPIR-V and convert it to C++ and run that. I converted some shaded toy shaders and made it run on the CPU. That never really went anywhere. There was no clear use case for it. It was really slow. So I kind of consider it deprecated or discontinued now. I don't really care about the backend anymore. It compiles, but that's about it. But Intel picked up the torch here, where they made a fork targeting ISPC, which is, if you don't know, it's kind of a way to auto-vectorize code for you. You write code very similar to a GPU, and it kind of converts that to AVX2. So it actually runs pretty fast, but it's limited to compute. But it's kind of what the Halcyon slide earlier alluded to. I think they're using that fork to target ISPC. So that's an interesting thing to check out. You can check out the Intel's fork of that. Basically, the threads in a work group maps to a lane in AVX or SSE or whatever. It's pretty cool. But among all the backends, Metal is the most important one. I think that's the only practical way to target Metal from a cross-compilation solution. At least that's open source. There might be others, I don't know about them, but I want to know if so. It's also part of the Portability initiative. You need to be able to convert SPIR-V to Metal. It's an important part. But I'd like to give out a special thanks to Chip Davis, who has implemented a lot of crazy advanced Metal backend features over the last year that I would probably never get to because they were extremely painful. I mean, they were painful to review, so I assume they were really painful to write as well. Yeah, that's happened. So the Metal backend is looking really good now. But it's not just multi-VK, it's also a project like GFX-RS, which should not be forgotten. That's kind of part of the portability umbrella. So I want to go through some features, which might have some more technical side of it. Metal tessellation is interesting in a very sarcastic tone. It's different from all the other APIs, which makes cross-compilation really hard. I thought it would be almost impossible, but it turns out it might actually be practical. So in Metal, vertex and tessellation control shaders don't exist, or hull shaders. You kind of have to emulate them if you want to work in the old way with SPIR-V or GLD, 3D, whatever. So we emulate this with compute shaders, basically. And the goal of the hull shading stage is to emit a buffer with tessellation factors, which is then consumed by some magic stuff which actually spawns the domain or evaluation shaders. So we kind of have to emulate this in a really weird way, and Walkin VK implementation has to do a lot of magic to set up all this state. I'm not sure how this even works with indirect tessellation, but apparently it does. One major use case that motivated this was to run DXVK games, which translate DX games into Vulkan, which then goes through Molten VK. And this apparently works in some games. I don't know why, but it does. But just don't rely on, please avoid tessellation, it's going to be horrible. So some example here. This is what, on the left is what the geocode would look like, some random crap tessellation code. But what you see in metal, I had to comment out a lot of stuff because this is like 400 columns of crap. And a lot of weird code that copies data in shared memory to deal properly with how tessellation control shaders work with data input and output. Stay away, stay away. Of course, war stories last year. I need one war story this year. That's image view swizzling. So you might know in Vulkan you have this thing called VK image view where you can specify a swizzle when you're sampling, which is a very useful feature in many cases. Even Glass 3 supports this, but it's not supported in Metal at all. DX12 supports it, Vulkan supports it, GL supports it. It's just Metal, of course. So normally we wouldn't bother with this, but it turned out for some games it was kind of important to have a path where we could dynamically swizzle all texture samples in the shader. Some games just need it. So yeah, basically in this mode, if you have to use VK image view swizzles, you can actually enable a path where it will look up a swizzle code from a buffer, put that through 4 loops of switch tables, and then it swizzles the texture for you. Don't do this, please. I mean, I kind of wanted to show the code, but it took like 5 slides to show the code. It was just don't, please. It's a sin to show that code. That's my biggest horror story for Metal. It's terrible. Some more useful features is the indirect argument buffer support. I've kind of put it on the back buffer for ages because there was, yeah, I thought it would be extremely difficult to implement. It's a Metal 2 feature, and if you know Metal, in Metal 1 you kind of have old school descriptors where you just put, here's a buffer, here's a texture, blah, blah, blah. It's very GL D311-esque. But in Metal 2 they introduced the argument buffer, which is kind of a superset of a descriptor set. So the idea is that we emit a buffer which contains references to resources, which is basically what the descriptor set is. It's just a little bit more abstracted. But here it's very direct. You can actually copy text, copy descriptors around, which is really interesting. But Vulkan doesn't support that, I think. Yeah, basically that's a path that will allow less CPU overhead in Molten VK, I assume. I'm not sure if they've implemented it yet, but it's on the roadmap, I think. So I implemented that. That was not too bad, actually. Just took a few days. There's also, this is where we get into crazy territory, variable buffers pointers. Or variable pointers is a very specific SPIR-V feature. It was introduced to support OpenCL and Vulkan, and OpenCL has pointer support, so there's kind of an extremely narrow view of what pointers are in SPIR-V if you are in the shader model. So it's actually possible to decompile that kind of SPIR-V code to Metal that actually has pointers. That's kind of cool. I'm very glad that feature was in before I implemented the buffer reference stuff, because that's basically the same kind of thing, except it's more weird, of course. But here's one of the few examples where Metal is nice and that it's okay. It's a C++ dialect, so you can do stuff like this, where you cannot in GLSL or HLSL. So, looking to the future here is that what's going to be the biggest pain points? It's going to be pointers. Because GLSL and HLSL don't support this. I assume there are going to be lots of crazy minor incremental intrinsics and fixes and minor extensions here and there to sort of inch towards full pointer support in the future, but that's something I'm really not looking forward to support. Because there's a big shift in SPIR-V where you have the kernel mode that has full pointer support, you can cast them to integers, you do crazy stuff, or you're in Walkin where everything is logical. Unless you start enabling various extensions to remove certain restrictions. But yeah, and then there's of course the flexible buffer packing rules that get more and more intricate, where you have the scalar stuff. Well, it's kind of simple in a way, but the original shading languages don't necessarily support that directly. So I still have 8 different cases of buffer packing rules to take care of, and just more work. Maybe someday everything is scalar and everyone will be happy. There's also a new C API. This is more like a maintenance kind of thing. If you try to use the API, you'll know that it's C++, there are lots of data structures. The ABI and API are not necessarily stable. I've always intended it to be linked statically in your application, so that's not a problem. But there have been some people who want to use it as a shared library, for example. So I've added the full C API where I commit to a stable API, so that can actually be shipped in a distribution, for example. That should be nice. And languages like Rust is all the rage now, and now you can maybe make a crate out of this. Someone is working on a C# wrapper, for example, that uses the C API. So it's kind of nice to enable SPIRV-Cross outside just C++. So some takeaways is, yeah, make SPIR-V your main target, go to that, and then hopefully use SPIRV-Cross to target everything else. If you're going for portability, that's my takeaway. And don't hesitate to file bugs in GitHub. Fixing bugs always takes priority, so if there are bugs, I will drop any future work and work on bugs. You just need a SPIR-V repro case, and if you have a particular sensitive repro case, like, oh, we have this particular game and we can't really give you a SPIR-V publicly, we can arrange that offline. Or with emails or something. That's possible. You can file feature requests, missing functionality you need, like say, I need very specific features to work in HLSL or method, you can file that. But also just random questions and support questions, like how do I use this API? I want to get this particular effect when you cross-compile to method or something. So that's stuff I can answer as well. I think that's my talk. Didn't go over time. Yeah, here's some info you can contact me on. Signal to noise ratio on Twitter is pretty high, so you can follow me there. Yeah. Any questions?
Yeah, I'll go on. I recently integrated GLSL as a library into my test app to call it directly, and it was a bit of a mess, to be honest. The API was awkward and not very consistent, and it was kind of hard to parse the errors that it threw out when the shader didn't compile. In a machine way, I had to write a bunch of regex to kind of try and extract which file and line number they were pointing at. And I actually saw recently on someone on Twitter making a joke about how all the shader compilers in the world never actually point you at the line where the error actually is.
Yeah.
So is SPIRV-Cross better in that regard? Is it easy to use as an API? Does it give consistent error results?
Yeah, so the error handling is mostly, well, so there are two kind of failure cases. One is where it finds out I cannot support this in my target language. Like you try to use a feature that's not possible. In that case, it will report that, like as a text string, but it won't necessarily tell you exactly where, because that might not be possible. I mean, you could maybe say this was the instruction in the SPIR-V stream that failed, but that's not very helpful either. You can't map that back to a line of source code. That would be, maybe it's possible. The other cases where there's a bug where it generates code that it turns out it doesn't compile after all. But that might be a case. Not sure if that answers the question. But generally, error reporting is a big problem. I'm not sure if SPIR-V solves it.
When you say target SPIR-V in your engine, do you mean generate SPIR-V, let's say from a GLSL, and then target HLSL and metal and everything.
Yeah, so I think there's two main paths here. There's either you write in GLSL, you go to SPIR-V, and if you target something else, you can cross-compile to that. Or you can start in HLSL, target SPIR-V, and then go through everything else. Well, with HLSL, you can just use Microsoft's compiler to target D3D or metal and GLSL. Yeah. So the idea is that you should, I mean, the whole goal of a shader pipeline is you write your shader once, and then you have the problems. How do you make that work on all the targets? That's the problem. And how you get there can be pretty annoying. There are lots of weird, I mean, some people end up doing text-based replacements and million macros and just sort of makes it work, but that can work in some restricted cases for HLSL and GLSL. It's similar enough in many cases that you can get away with it, but not metal. That's just impossible, I think. Yeah.
Tessellation shader support you mentioned, that's on all backends or just metal?
So Tessellation is supported in fully in the GLSL backend. That's pretty easy. There is metal support. Although I'm not sure how good it is. I mean, the initial pull request was over 1,000 lines of code. There must be a bug in there somewhere. HLSL doesn't. I don't support cross-compiling to HLSL because no one has really requested it, and it might be very difficult. Yeah, that depends on. I mean, if no one needs it, why? Kind of a niche. I think cross-compiling to HLSL Tessellation would be a very niche feature. Yeah.
What are your thoughts on Microsoft's shader conductor?
The library?
Yeah.
I haven't used it. I just saw that they did that and talked about it. I haven't tried using it. But I included it there because it plays into the idea that many people are going HLSL to SPIR-V. And it was very interesting to see that they also have the same ideas about how the cross-compilation chain can work. Guess that's it.